Good afternoon, children. Today we will be doing preparation of hydrochloric acid. Till now you have studied hydrogen chloride gas, its preparation, properties and everything. Now hydrochloric acid. Now you must be wondering, what is the difference between hydrochloric acid and hydrogen chloride gas? Both are HCl. HCl, hydrogen chloride gas means we say HCl, correct? And hydrochloric acid also HCl, correct? But the major difference is, when I say hydrogen chloride gas, it's a covalent compound. It's a poor conductor of electricity. Got it? It does not, conduct electricity in the gaseous state. But when I say hydrochloric acid, it is aqueous. It is ionic in nature. It dissociates into ions in aqueous solution. It conducts electricity because due to the presence of the free ions, it helps in the conduction of electricity. So that's a basic difference. HCl gas is covalent, but hydrochloric acid is acidic in nature. It conducts electricity. It shows the properties of acid, we can say that. Clear? For example, if you pass an HCl gas through dry litmus paper, no change you will see. No change at all. Alright? Because in the absence of moisture, it will not dissociate into H plus ions, and without H plus ions, it will not show the properties of acid. Alright now? Now, how to prepare the hydrochloric acid? You will say, sir, we will pass the gas through water. It is done. Okay, fine. But it's not so easy because there are some, problem involved in it. We cannot directly pass the hydrogen chloride gas into water. Now, see the figure. The first one, figure A. We cannot do this. Got it? That HCl gas, delivery tube, directly we pass into water. And we prepare hydrochloric acid. We cannot do it. Why? Because it causes back suction. Direct absorption of HCl gas in water using a delivery tube causes back suction. Now what is back suction? See that on the screen what I have given you. The pressure outside being higher, the atmospheric pressure, causes the water to be pushed up into the delivery tube and damages the apparatus. This is called back suction. See, when we pass the delivery tube or when we dip the delivery tube directly into water so that HCl gas directly passes into the water. Now remember that HCl is highly soluble in water, we have studied. 452 volumes of HCl is soluble in 1 volume of water. So listen carefully. The rate of production of HCl is much more, is slower than the rate of dissolution of HCl in water. The rate of production of HCl is comparatively slower compared to the rate of dissolution of HCl gas in water. That means HCl gas dissolves faster in water than it is being prepared. Alright, that is what is. So hence what we find is that HCl gas dissolves faster in water. So when HCl gas dissolves faster in water, what will happen? A vacuum is created inside the tube, the delivery tube, because at that time HCl is not being produced. HCl is dissolved. Got it? HCl gas, whatever it is there in the tube, it is dissolved. By the time the HCl is not produced in the in the conical flask. So a vacuum will be created in the delivery tube. And hence the water will rush into the delivery tube. The water will rush inside the delivery tube and it will go back to the hot flask. When it will touch the hot flask, what it will happen is that the flask is going to crack. This is known as back suction. This is called as back suction. Got it? What I said to you here, the pressure outside. So which pressure is higher? Atmospheric pressure is higher. The pressure inside the tube is lower. Got it? Due to which, that is to equalize the pressure, the water rushes into the delivery tube and it goes to the the hot flask. And as a result, it cracks the hot flask. Got it? Now, hence, this is called as back suction. I think you understood what is back suction. Fine. Now the question is how to avoid this back suction. We can avoid it by using a funnel arrangement. Got it? See, I have written it on the screen. You can see it on the screen. Funnel arrangement is used for avoiding back suction. That is, it prevents or minimizes back suction and also it provides a large surface area for absorption of HCl. Now you will say how? Now you come to the figure, that is B bit 1. So instead of delivery tube, if I use a wide mouthed funnel, the mouth should be as wide as much it can be. Alright, so wide mouth funnel, and what we have done it is here, you can see it here on the screen that I have placed the funnel just above the water, just above the surface of the water I place the funnel. That means the mouth of the funnel is touching the surface of the water. Alright, it's touching, that is not dipped inside, it's touching the surface of the water. Okay, fine. So even if the back suction is going to take place, as you can see in the bit number 2, bit number 2, the water is rising up to the mouth of the funnel only. The water is rising, okay, due to which a gap is being created between the water and that of the funnel. Alright, because the water is going to rise to the mouth only, as you can see there. So a gap is being created between the water and the mouth of the funnel. You can see a gap is created. So due to this gap, you can see the atmospheric pressure now acts from above, and it pushes the water back into the trough. Alright, due to which water cannot go back to the hot flask. This is how back suction is being prevented. Got it? And this is called as funnel arrangement. See, instead of funnel arrangement, you can use also a pipette. I have told you in titration, pipette, which is used for sucking purposes, sucking the liquid, that also can be used. Got it? Pipette, what you can say, we are having a long tube. Alright, you just replace the delivery tube with a pipette, you just attach a pipette. So what will happen is that the water will come inside the pipette only, it will not go back to the delivery tube, and as a result it will not go back to the flask. Alright, clear? How it is so? You can see in the figure B, bit number 2, the atmospheric pressure, you can see the 2 arrows. The atmospheric pressure is acting from the sides, and it pushes the water again back to the trough. The water does not, what you can say, go back to the hot flask. The water rises in the funnel, no doubt about it, but the water cannot go back to the, what you can say, to the hot flask again, because you can see it here again and again I am repeating. Alright, the atmospheric pressure pushes the water because there is a gap between the water and that of the funnel, because you have placed the funnel just above the level of the water, just above it. So when the water rises, it rises only to the mouth of the funnel only, due to which the level of the water falls inside the trough, and as a result the atmospheric pressure acts upon it, and hence it pushes the water back into the trough, due to which the water cannot go back. This is how back suction is being prevented, and this is called as funnel arrangement. And in this way we prepare hydrochloric acid. We do not directly dip the delivery tube into the water, but by using a funnel arrangement we prepare hydrochloric acid. I hope it has been clear to you what is the function of, that is the funnel, and why do we do the funnel arrangement. I hope it has been clear. In this way prepare HCl, what you can say, acid from HCl gas. Now next is the properties of hydrochloric acid. The properties is similar to that of HCl only. The only properties I said you that it is ionic in nature, it conducts electricity, and a solution of HCl in water forms a constant boiling mixture with water when the boiling point is 109.8 degrees centigrade, and the weight of HCl is 22.2% by weight of HCl. Now what is that constant boiling mixture? See, now when you have prepared an HCl solution, which HCl solution you have prepared? Dilute HCl solution you have prepared it? Definitely, because you have dissolved HCl in water. So the solution which you got, it's a dilute HCl. Now you will say, sir, I want to concentrate the solution. Concentrate means what? You want more of HCl, less of water. That's it, inside the solution. So what you need to do? Simply boil it. Simply boil it. What will happen? Water will evaporate, leaving behind the HCl that you wanted. But can you think that you can boil off the water completely 100% and you will get only the concentrated HCl? No, it's not possible. By boiling, you can concentrate the HCl up to 22.2% by weight of HCl. Try to understand what I am speaking to you. You have taken the dilute HCl solution, you are boiling. Simply you are heating, evaporating it. What is happening? Water is evaporating, HCl is remaining behind. Can you do it completely, that water, all the water will evaporate and HCl will remain behind? No, you cannot do it, because beyond a particular temperature, what will happen is that HCl will also evaporate. So that particular mixture is known as constant boiling mixture. So what is the composition of mixture at that particular time? And what is the temperature? The temperature is 109.8 degrees centigrade. That means beyond 109.8 degrees centigrade, HCl also boils off along with water. Alright, and what is the percentage by weight of HCl in water? 22.2%. Alright, 22.2% by weight of HCl is present in water. That means out of 100%, 22.2% of weight of HCl is present. So you might be thinking, so can't we then concentrate the HCl beyond it? Yes, we can do it. There is another method. The method is you will be boiling the HCl in presence of concentrated sulfuric acid under pressure. Got it? Concentrated sulfuric acid acts as a dehydrating agent. Got it? And it absorbs the moisture, it absorbs the water. Then you can concentrate it much more beyond this. That is, you can concentrate it up to, let us say, 95% or 96% you can concentrate it. Okay, that you can do it. Clear? So understood the properties of hydrochloric acid. That is, it is corrosive in nature, it is same thing having sour taste, it is slightly pungent odor, it is colorless in pure state. When it falls on the skin, it causes painful blisters if it is falling on the skin, and it is having a density slightly more than that of water, that is 1.2 gram per cc. We can see that. Clear? Alright, the preparations. Thank you very much.